Okay, here's sample problem 1614. Aspirin, which is called acetyl salicylic acid, has the chemical formula HC9H7O4, is a weak acid. It ionizes in water according to the equation. HC9H7O4 aqueous plus H2O liquid forms H3O plus aqueous and C9H7O4 negative aqueous. So aspirin, acetyl salicylic acid, reacts with water as a weak acid to form hydronium and the salicylate ion. It's called salicylate. That's the conjugate base. So a 0.10 molar aqueous solution of aspirin has a pH of 2.27 at 25 degrees C. Determine the value of Ka for aspirin. Okay, so this is that third type of problem I discussed in the lecture. So the idea here is your aspirin, HC9H7O4, is going to react with water to form hydronium and salicylate. Okay. And we don't know what the Ka is. They don't tell us, so you could look it up somewhere. It's probably pretty small. So what we're going to do is we're going to put together an ice table. The initial concentration of the aspirin is 0.10 molar. Water's a liquid, so don't worry about that. These are both 0. Again, Q is going to be 0. So minus X plus X, the reaction goes to the right. And then at equilibrium, this would be 0.10 minus X, and this would be X and X. Hydronium at equilibrium is equal to X. They tell us the pH is 2.27. So from that, we can determine the hydronium concentration. 10 to the minus pH, which is 10 to the negative 2.27. To the x, right? 5.37 times 10 to the minus 3. There's our hydronium concentration. That's equal to X. So not only is that number here, it's also here and here. So that means that Ka, the ionization constant, would be X times X over 0.10 minus X, right? So that would be 5.37 times 10 to the minus 3 squared over 0.10 minus 5.37 times 10 to the minus 3. Okay. So 5.37 times 10 to the minus 3. We're going to square it, and then we're going to divide it by 0.1 minus 5.37 times 10 to the minus 3. And that gives us 3.05. I'm going to round it to 3.0 times 10 to the minus 4. There's our equilibrium constant. We figured out Ka from the ice table by measuring the pH, which gave us X, and we also needed to know the initial concentration of the acid that we're dissolving. that initial concentration will affect what the pH is. So the value of X depends on the initial concentration, and it also depends on the value of Ka.